Good morning to all. How are you? Fine? Okay. Listen. Already you have studied about different concepts in current electricity. Remember? Okay. So now we are going to discuss about internal resistance of a cell with the help of potentiometer. Okay? Listen properly. Okay. Measurement of internal resistance. It's a symbol that is very, very important. Smaller of a cell by, that means with the help of potentiometer. Already you have discussed, studied about potentiometer and a meter bridge and also Ohm's law. Remember on that? Okay. Right. Okay. Now, measurement of internal resistance. That means we want to calculate a small R value of a cell by potentiometer. Okay. Then, listen now. So this is battery. This is key. This is not lines, okay? This means wires, okay? Keep in mind. Battery, key K2, and this is potentiometer. Already you have studied about this. Large size wooden box. Remember or not? Okay. This is potentiometer and this is cell. It's EMF capital E. But in your textbook given like this, like XII, don't use like this, okay? You must write like this, E, caps E, or you can use like this, no problem. But don't confuse. At one place you put this symbol, another place this symbol, like that. Suppose you use this symbol, you must always use at the time of completed this question. Okay? Use any one symbol. This or this. Okay? So you can now use this symbol. This is very, very important. Caps E. That means EM of this symbol. Okay? Galvanometer. High resistance. This is jockey. You have already seen, I think, galvanometer and high resistance, etc. Okay, this is jockey. This is K2. key. This is a resistance box. This is the cell. So here we want to calculate this internal resistance. Okay, right. So this is the circuit diagram of measurement of internal resistance of a cell by using potentiometer. Okay, listen properly. This is a circuit. Battery key. Sorry, this is K1. Sorry, this is K1. This is potentiometer. This is the cell. This is the resistance box. Right? Come on, take your textbook. Write on the diagram. After writing these words on your diagram, then you can write the explanation of this circuit only, without any confusion. Clear? Yeah. Battery. Come and write down. Key, that is called K1. This is potentiometer. That is potentiometer. This is cell. This is galvanometer. This is high resistance box. High resistance. This is external resistance. This is key K2. Okay, right. Next. So first, now we are going to writing about explanation of this circuit diagram. You can write only, no problem. Two ends of potentiometer. This is two ends of potentiometer, C and D. So the end C of the potentiometer connected with the positive terminal of the battery. I am correct or not? Large size line positive, smallest size negative line. Negative. The end C of the potentiometer connected with the positive terminal of the battery. Then the end, that means the negative terminal of the battery, not end, the negative terminal of the battery connected with the end D of the potentiometer through key K1. Clear? Then the positive terminal of the cell of EMF caps E connected with the end C of the potentiometer. Then negative terminal of the cell connected with the jockey. Already you have seen, I think. I am correct or not? Jockey. Through galvanometer and high resistance. Negative terminal of the cell of EMF E connected with the jockey J through galvanometer and high resistance. Okay? Then. Come on, write in your textbook like this with the dotted lines. This point is J dash, not given, but write. It is very, very useful to writing the explanation of the diagram only. Okay? This is point J, this is J dash. And also, this gap, come on, write down in your textbook. L1, not given this also. Okay? At the same time, this is this gap, L2. Very, very interesting question this. Simplest question this. Okay? Compulsory. No question paper without this question in your examination. Okay? So listen properly. Come on, finished? L1 and not given in your textbook. L1 and L2. Okay. Then the external resistance of resistor of resistance R connected across the cell with the key K2. That means external resistor of resistance R and K2 connected with the series are connected across the cell. Okay, that's all. For example, its resistance say 10 ohm, for example. That's all. Okay, that's all. Okay, now listen properly. Okay, listen properly. Now, K, this is pressed, already pressed, no problem. Now, K2 is open. First, K2 is open. Listen properly, line by line. K2 is open. That means cell, it is in open circuit, not closed circuit. Open circuit. Open circuit. Okay. K2 is open. Now, this is jacky. This jacky should be moved on the potentiometer wire. Okay. On the potentiometer wire until the galvanometer shows null deflection. What is null deflection? Zero deflection. I am correct or not? Until you must move the jockey on the potentiometer wire shows null deflection. Null means zero deflection. Zero deflection. So the balancing point J is obtained. Balancing point J is obtained. And shows null deflection in galvanometer. Then the balancing length. Already you have studied about this balancing length in potentiometer. Cj, that is the balancing length. It is equal to L1. So balancing length Cj is measured. It is called L1. Clear? Okay. Then according to principle of potentiometer, come and tell me what is principle of potentiometer? Yourself? Yeah. Come and say. Very good. The EMF of the cell is directly proportional to balancing length. Okay. The EMF of the cell is directly proportional to, very good, its balancing length. So according to principle of potentiometer, in open circuit, that is important. In open, not a closed circuit. In open circuit, EMF of the cell is directly proportional to balancing length. Here balancing length Cj, it is equal to L1. Okay, that's all. Clear? Then now K2 is pressed. Okay. Now K2, this is key, is now it is open. Now this is closed. K2 is pressed. This is key. Now it is in closed circuit. Clear? So now again the jacky. It is moved on the potentiometer wire until the galvanometer shows null deflection. The galvanometer shows null deflection. Clear? Therefore, now the balancing point J dash is obtained. Balancing point. And also balancing length C J dash is measured, that is equal to L2. Clear? In closed circuit, Cj dash is equal to L2. Keep it in mind. Okay? At the same time, so after key is pressed, so current passes from this cell through the circuit. Okay? through the circuit. That is called I. That is called I. Okay. How do you write the basic formula for I? According to Ohm's law, V is equal to IR. All IRs are vegetarian. Ella irugume vegetarian. Keep in mind like this. All IRs are vegetarian. So IR is equal to that like IRs. It is equal to V. So V is equal to IR. It is Ohm's law. I is equal to V by R. I is equal to V by R. Instead of V, you must write E. That's all. I is equal to E by R. Okay. What is I? Current. EMF. Resistance. That means a total current. Total EMF. Total resistor. Total. Clear? So, total current I. Okay. EMF E. Okay. But total resistance. See here. Already external resistance connected across the cell and key also. Already it has small resistance, small r. That is called internal resistance. I am correct or not? So, one external resistance, one small resistance. I am correct or not? Now both the resistors connected in very good series. So total resistance, effective resistance Rs is equal to R1 plus R2. No, already you have studied about resistors connected in series and parallel also. Remember that. And this R is equal to R2. That means a small r. That is a total resistance. Okay, so R plus small r. Clear? Then V is equal to IR. That means after key is pressing, now this is in closed circuit, current passes through the circuit. At the same limit, no need. At the same time, this entire circuit is called a primary circuit. Keep in mind. Primary circuit. Okay, leave it, no problem. K2 is pressed, that is called, now it is in open, closed circuit, not open circuit, closed circuit. Current passes through the circuit. Okay, at the return, I is equal to E by R plus R. At the same time, potential difference exists across this resistor of resistance caps R. Okay, that is called V. Potential difference across R caps R, that is called V is equal to IR. Okay, so V is equal to I, okay, R value, sorry, I value E by R plus R into caps R. Small r internal resistance of the cell. Compulsory we want to calculate that value. Remember, small r value. Caps are its resistance, external resistance. Okay. So V is equal to ER by R plus R. Okay. Capital E in closed circuit or open circuit? Very good. You yourself, correct. Open circuit. V, it is in closed circuit, correct? Okay. In open circuit, according to principle of potentiometer, EMF of the electromotive force, EMF of the cell is directly proportional to balancing length. Here balancing length L. In open circuit or closed circuit? Open circuit. Keep it in mind. In closed circuit, after pressing key K2, Now it is in closed circuit. Balancing point J dash is obtained. At the same time, balancing length C J dash, that is called L2, is measured. What happened here? Listen properly here. Very good. L1. Comparing L1 and L2. L2 less than L1. Okay? This is one important point. Keep in mind. It is very useful to solving the problems relevant to potentiometer or to find out internal resistance of the cell. Okay? Keep in mind. Okay. Now, E is equal to ER by R plus R. At the same time, again, principle of potentiometer, in closed circuit, not open circuit. V or E, V again. V proportional to balancing length now, L1 or L2. Very good, L2. Okay. Now V, open circuit E, in closed circuit V. Always V less than E. Hence, okay, 1 point. Again 1 point, keep in mind. V less than E. Potential difference across resistor always lesser than its EMF of the cell. So, what will be balancing length also decreases, no? Yes, decreases. Keep in mind. So, V proportional to L2. Okay, what is V value? Okay? ER by R plus R proportional to L2. Equation number 2. That's all. What is our motivation in this question? You want to calculate internal resistance of the cell. Okay, small r value. So we want to calculate small r value. Okay, what to do here? Think and say. What to do? Think and say. Yeah, here taking equation number 1 and 2. Clear? That's all. Equation number 1. E proportional to L1 R. E is equal to constant into L1. Equation number 2. ER by R plus R proportional to L2 R. ER by R plus R is equal to, again one constant, into L2 into L2. Clear? Listen properly. Into L2. L2. Okay, what would I hear? Very good. 1 by 2. Equation number 1 by 2. That's all. Now, what is equation number 1? E is equal to constant into L1 by 2 ER by R plus R. By constant into L2. That's all. Very simple, that's all. We are going to now climax. Yeah, yes. Constant cancel, okay? What's the remaining? E by ER by R plus R is equal to L1 by L2. This is L1. In open circuit, at the same open circuit, current does not flow. So galvanometer shows null deflection. Keep in mind, null deflection. Cj dash. Now that is called L2. So L1. So E by 1 R plus R by ER is equal to L1 by L2. Clear? Okay? So, E cancel. What's the remaining? R plus R by R. Okay? Is equal to L1 by L2. Very, very interesting question this. Very, very important also. 5 mark question. Or 3 mark. 5 marks or 3 mark. Okay? See again. Okay? So this term we can split it as R by R plus small r by caps R. R by R plus R by R. It is equal to L1 by L2. Okay? Then that's all. Very simple. Okay? Caps are cancel. What's the remaining? Very good. 1. So 1 plus small r by caps r is equal to L1 by L2. That's all. What will be next step? Okay, we have to calculate here small r. So keep it here, left side. And goes that side. L1 by L2 minus 1. That's all. So small r is equal to L1 by L2 minus 1 into caps r. Okay? Clear? That's all. So it is called internal resistance of the cell. Small. Internal small. External large. Its value. So caps r. Its value. Caps r. Okay? That's all. Small r is equal to L1 by L2 minus 1 of caps r. That's all. Very, very important formula. Very, very important formula. Or in another form, small r is equal to cross multiplication. No. 1 means 1 by 1. Okay? 1 means 1 by 1 into r. Come on, taking cross multiplication. 1 into L1, L1. 1 into L2, minus L2. By 1 into L2, L2. So, L1 minus L2 by L2 into r. Another formula. To calculating internal resistance of the cell. Okay? Very, very important. Okay? Clear? So, on substituting the values of L1 and L2 and R, its value. Now it gets internal resistance of this. Come on, any idea in your mind? What's the relation between small r and caps r? Come on, tell me. Small r and caps r. The same experiment repeated for different values of caps r. For example, here say 10 ohm. Okay, for different values of r. Okay, so L1 is various, L2 also correspondingly various. So L1, L2 compulsory will be constant. Okay, so for different values of caps r, compulsory small r value increases with the increasing caps r value because this is constant. Okay, so small r proportional to caps r. So for different, the same experiment repeated for different values of caps r, small r it is not constant. Not constant, but increases its value with increasing capital R value. Okay, very simplest to proceed this. Okay, again, see one by one, go through one by one, go through quick, very, very interesting concepts. Go through entire derivation fully and recall the main concepts in your mind about this question. Come on, revise about open circuit and a closed circuit and L1 value and L2 value and a capital R value. Revise. Okay, that is two formulas. Last formulas there. Last. These two formulas. This is to find out internal resistance of the cell. Of the cell. Clear? Okay. Shall we move to discussing one problem, just one problem relevant to this question? Ready? Are you ready? Okay. Okay, come on, listen. Take your book. Page number 114. Textbook. 114, page number. First volume. In the mark. 114. See this circuit diagram. Come on, properly. After seeing this circuit diagram, read word by word. Very simplest problem. In a potentiometer experiment, the galvanometer shows null diffraction. Galvanometer shows null diffraction. Null diffraction means like this. Null diffraction. When a cell is connected across, listen, it is cell, this, connected across 60 centimeter of the potentiometer wire. 60 centimeter of the potentiometer wire. If the cell shunted means a parallel combination, parallel, across the cell. So cell is shunted by a resistance, its value caps are, okay, of 6 ohm. This 60 centimeter, this 6 ohm, the balancing point now is obtained across 50 centimeter. Okay. So what is this? L1 or L2? Very good, L1. Because of comparing 60 and 50. L1 biggest value, no? So very good, L1 60, L2 50, that's all. That is caps R value, that's all. Shunted means across, that's all. Parallel, no problem. Of the wire, the internal resistance of the cell is, come on first, that's all. Internal resistance of the cell is L1 okay, L2 okay, R okay, okay. Internal resistance of the cell is okay. What is symbol for internal resistance? Small or no? Formula. Come on, tell me. L1 minus L2 by L2 into R. No, the two formulas. You take any one formula. Option is 0.5, 0.6, 1.2 and 1.5 ohms. Come on, try yourself. Anybody? What is the value? Try quick. 0.5? Yourself? No. 0.6? No. Yeah, very good. Yourself correct. 1.2. How? L1 value 60, L2 50 and L2 50 into caps are 6. That's all. 10 by 50 into 6. 6 into 10, 60 by 50. 6 by 5, 1 5s are 5, remaining 1, 2 5s are 10. So, small r is equal to 1.2 ohm. That's a very simplest problem. Okay.